So for here, we're gonna start calculating the E standard cell, E actual, and delta G free energy for the following cell reactions. What we're gonna do is we're gonna start on the second part since we already went over the first part, and this is gonna be a little faster than last time. So what we're gonna do is the first thing is we're gonna go into a half reaction here so we can find out what our cathode and our anode actually are in order to find our E standard cell, which is the first thing we need because you need your E standard cell in order to get your E actual, in order to get your free energy, Gibbs free energy. All right, so we're gonna start off, we see here, we start off with a half reaction, and with our half reaction, it's gonna be 3 zinc solid. It's gonna yield a zinc 2 plus charge. And here, you're gonna see that from here to here, you actually lost 2 electrons. So you're gonna add 2 E minus. Okay, so if you see here that you actually lost 2 electrons, you're gonna realize that this is oxidizing. And if it's oxidizing, it's your anode. Okay, so you have your anode, which is oxidizing here. So remember your values, A and O, they go together. Anodes oxidize, okay? And you could just see here how zinc, when you write your half reaction, you come here, you're losing 2 electrons, and then your anode is coming in. All right, so then now you're gonna go into your chromiums. So, you know, for me, I just write my coefficient right at the end, and it's gonna be Cr3 plus is going to here, you're actually gonna gain 3 electrons, so it's plus 3 electrons here, and yield, and then here's where you have your chromium solid there. So if you see here, if you actually look at the charges, you're going from a 3 plus to 0, so a 0 charge. So you're actually gaining 3 electrons in order for you to go to your 0 charge. So if you're gaining your electrons, you know this is a cathode, and you can remember your cathode is reducing. So reducing is gaining. Okay, so if you remember constant C and R and then O and A, you'll find out exactly what it is. And when you look at the charges here, okay, so this is going to be provided to you in a chart, how they go and your voltage and everything like that. So if you look at your zinc chart, you're going to be able to see that your anode's actually negative 0.76 voltage. And if you look at your cathode, your chromium, and you look on the chart, you're going to be able to see that it's going to equal negative 0.74 voltage. And here what we're going to do is we're going to do our cathode minus our anode, as you can see here, in order to get our standard cell. So our cathode minus our anode. Alright, so in order for our cathode minus our anode, we're going to look here, we see that 0.74. So we go negative 7.74 volts. We'll minus our anode, which is negative 0.76 volts here. And you simply just add them, and when you're going to get your answer, it's going to be 0.02 volts, and that's going to be your E standard cell. Okay, so here, so now we have our E standard cell. We're going to go ahead and come to our E actual. So here we're going to find our E actual. As you can see here, you know, everything's already laid out. We have our equation, so we can plug everything in. So our E actual is going to equal our E standard cell, and we know that our E standard cell is 0.02 volts. So we go ahead and plug that in here. 0.02 volts, and you're going to minus 0.0592 volts all over the number of moles. You see here your number of moles, as you can see. So our number of moles here is actually going to be 6 moles. If you look at your charges, you're going to want to equalize them. Here you multiply the opposite, so you multiply this by 3 and this by 2, and in other words you're going to get 6. So here you're going to put your 6 right in, and now you're going to use your log Q, which is the reaction quotient. Now, so it's going to be multiplied by log and Q, and remember your anodes over your cathodes. But when you look here, everything's already provided for you. Okay, so we know that our cathode is going to be our chromium, which is 0.070 molarity. Our anode is 0.0075 molarity. Okay, the thing is, what we're going to remember here is a coefficient on top. So if you see this coefficient and you have this 2 chromium coefficient, you're going to want to put the molarity, because your coefficient is going to be here, 3 zinc 2 plus, you're going to put the 3 up here, and then same thing with here, you're going to put the 2 here. So make sure that you actually pay good attention to that when you're putting the concentration. Fortunately, they give us the concentration. So here you will put 0.0075, and then this is going to be cubed, because remember that coefficient that was in front of it. And then also you're going to have 0.070, and this one you're going to square. Okay, so make sure that you do put your exponents here. Do not forget those, because you know it might happen. And from that, when you solve everything out, you solve this equation out, you will get 0.060108 volts. Okay, so it's going to be 0.060108 volts. Now that we have that, we can actually go to our Gibson's free energy. And this is going to be a rather simple equation now that we've finished everything up. Okay, so we got Gibbs free energy equals the negative number of moles of electrons times Faraday's constant, and your Ecell, which is your Ecell potential. And we've already earned everything that we need to get. So we're going to start here. So we're going to get our delta G. Okay, and it's going to be negative number of moles. Now, if you remember, we got our number of moles here in our last equation, which is our number of moles here. And if you go all the way back, if you forget for some reason, you can get your moles from here. 3 and 2, multiply them, you can get 6. From that, you just add the 6 here. Add the 6 here. Times Faraday's constant, which is 96,500 joules per volt times moles. Let's not forget moles here. Sorry. Moles. Okay. And then it's going to be multiplied by your Ecell. Your Ecell, if you remember, is the same exact number that we got here, 0.06018 volts. That's what we solved for earlier, our actual EMF, electromotive force. So we'll just go ahead and plug that in here, 0.060108. And don't forget, when you have this equation, that you're going to want to convert from joules to kilojoules, and you can do that simply by putting 1 kilojoule over 1,000 joules, and that's going to be your equation. So I'll just put that in, -6 times Faraday's constant times your Ecell potential, and then you're going to convert it from kilojoules to joules. And if you do everything correctly, your free energy is going to equal negative 34.8 kilojoules. And that'll be your final answer here. And just to reiterate, we calculated our E standard cell, and then our E actual EMF, and then from there we went to Gibbs free energy. Okay, and this is how we did it. We got the half reaction, determined our anode and our cathode. From there we were able to use our equation to find our E cell. Once we found our E cell, we're able to use that to plug into your E here, your E actual. You plug everything in here, you're going to get your equation here. Remember, you choose your concentrations. Don't forget to move your coefficient if you have a coefficient on top. And once you're done with that, you get your E actual number here. With your E actual number here, you're going to plug in here your number of moles and Faraday's constant. You're going to convert it to kilojoules, and then you're going to get your free energy. It's that simple. Have a great day. My name is Stewart. Bye.